Microphone's in the right place. Okay. Hello and welcome to the AI Business Podcast. I'm Tian, the creative producer of Informa Tech, and joining me is the man with the fancy title, the global editor of AI Business, Max Smolax. Hello, Max.
Hello there, guys.
And joining the podcast for the first time is our contributing reporter, Sebastian Moss. Hello, Sebastian.
Hello, everybody.
And on episode 2 of the AI Business Podcast, we will discuss the future of warehouse and how a company called Covariant is helping us with our Amazon order during the lockdown. It's very important. And watch out for the world's latest supercomputer developed by Microsoft and OpenAI. Plus, Mac's favorite topic, the future of the GPUs. And of course, the future of killer robots. And how far are we from the robot dog in Black Mirror? That's all I want to know. And finally, after a decade of hard research and lots of resources, is the human brain a useful model for artificial intelligence? Or should we look elsewhere? But first of all, Max and Sebastian, how are you guys doing?
I'm alive and I'm employed, so I'm good. I can't complain these days.
Sounds great.
But the weather is getting better and we're stuck indoors and I'm sweaty in my loft. It would be much easier in winter, right?
Don't give me these mental images, Max. We're trying to get more listeners, not lose them.
Thanks for bringing up, the word sweaty for the first time.
I'm opening the season.
And so while we're in the lockdown, so let's talk about this company, Covariant. They're getting a lot of money, a lot of attention. They're being covered, building this very impressive robotic arm they're able to sort through thousands of items, and it's helping us right now.
Warehouses are slowly getting automated, but we're not quite there yet because the biggest challenge that we have to overcome if sort of like for fully automated warehouses is something called picking. It's literally taking an item from one box and placing it into the other. And up until now, people just haven't been able to develop a robot that can do this simple thing, like just pick an orange to take it from one box and put it in the other box. This is why Amazon warehouses involve people, but there's a race going on to get people out of Amazon warehouses, and this is where Amazon is a little bit like Uber. So Uber drivers are the same as Amazon warehouse workers in the way that they're just an interim solution. The company doesn't need them, it doesn't want them. They're a complicated, expensive, bloody thing, and the sooner they can get rid of it, the better. So that's the goal for Uber. That's the goal for Amazon. And eventually, are these warehouses going to be automated? Absolutely. Is this a billion dollar problem? Yes. And this is what makes Covariant interesting because they've battle tested their technology against 10 other companies, right? And they won.
I read this statement by the CEO, Peter Chan, and he said he wants to empower robots to do a bunch of things they're not previously allowed to do. And I just thought it's amazing that we're in 2020 and the word empower is being used on robotic arms.
Yeah, we haven't really empowered all the people yet.
Robotic empowerment's probably going to make it harder for the people to feel empowered, but it's a story for another day.
What Max you're saying is that I saw news about the angry Amazon workers, how they're risking their lives going to the warehouses. And this man angrily yelled at a reporter and said, I'm risking my life working at the warehouse, and here I am packing a dildo into your order. You don't need an effing dildo during a pandemic, which is actually, it's an argument. It's debatable.
Yes, I'm glad we agree on that. Yes, exactly. Just essentials are very different for different people.
I apologize for making that order, but, desperate times. Right. I mean, this is the interesting thing. So you have robots, maybe like Covariants, that are great at picking things. Let's hope. But how do you actually tell it, hey, I want you to pick this thing from here, move it onto this production line here, have it ship along, then another robot spins it or whatever, right? That's really hard to actually tell a machine how to do that, especially if you yourself are not some fantastic AI programmer. So this week at Microsoft came out with Project Banzai. And what it is essentially they create a virtual replica, a digital twin of that robot. And then you, the non-AI person, can tell it what to do in that virtual world. And say, no, pick it up here, and you get it, do it again and again, constantly feedback, say you did it right this time, you did it wrong this time, train it again and again and again, to eventually it's doing exactly what you want, and then you put it into the real world, and it does it in the real world, hopefully, without any problems. And already they've got like a giant cement companies doing it, seeing a lot of results, and we're going to see more of that this year as it kind of rolls out. It's currently in public preview.
So the best way to describe it is a sort of like a virtual labor camp / re-education facility for robots.
Yeah, like that, but maybe even more depressing if you're a factory worker, but fascinating if you're looking at an efficiency side of things, or how do I actually get these machines that are in themselves dumb, giant, strong slabs and get them to do often quite technical and unique movements.
Yeah, and especially because for the next couple of years, these machines will have to work alongside people. So while fully automated warehouses are the end goal, but actually at the moment, the very, very important sort of like aspect of working with robots is how to combine the two safely, right? How do you have a factory where you just like giant machines which can crush you, like very, very easily? How do you get soft and squishy people in the same space, and how and not get them to lose their heads? And this is something where AI is also being applied and where AI can help. And I think that's mostly kind of like like sort of like big manufacturing houses like ABB, like the guys who actually sell these robots.
Right, and ABB were the ones that signed a deal with Covariant, which is so interesting. But I think what a lot of them are looking at is a thing called biomimicry, which is what can the real world teach us, and we'll talk about that later when we talk about human brain.
I know it's hard to predict. How far from us now can we expect to see a fully automated warehouse?
Basically, as soon as they sort out the picking, and it looks like it's already happening, because in terms of like moving boxes around and shifting them around, it's just like that's a done deal, right? We've all seen these videos. It's just like Ocado in the UK or Amazon in the US, or I think it's Baidu in China, right? They're making their own robots, and all of these things, they don't look like robots at all. They look like tiny little stools on wheels that can essentially, the only thing they can do is turn around and raise and lower the box.
So Amazon, obviously, with picking, they have an annual picking challenge so if you're a company right now that has picking technology, look into that because there's a lot of money to be made in that. But if it's something more complex, then it gets a lot harder. It depends how many different steps and how unique each step is. The more production line it is, the easier it is just to say, hey, robot, you do this.
Wait, aren't Teslas are manufactured pretty much fully automatically? Don't they have a fully automated production line? Or am I kind of imagining things?
You're not imagining things. What happened is Elon Musk got very excited about robots, said the whole factory, the machine that runs the machine is the most important thing, spent a lot of money, ran through many different executives, and then admitted that they'd overstepped. So they had too much automation that wasn't ready. And so you had poor little human workers who may or may not have filed some lawsuits against Tesla, who had to kind of slot in between when they weren't meant to be humans and get the thing moving, get the thing working. So they're actually reducing their level of automation right now, which is quite interesting.
You've heard it on AI Business.
But there was actually an Elon Musk related story that came out of Microsoft Build that I did want to talk about.
Right.
And he's no longer involved with this company, but it's still a fascinating tale and probably the biggest thing that came out of Microsoft Build. And that's of OpenAI and what they've done with Microsoft. So if you don't know OpenAI, they're like really Silicon Valley royalty. They had Elon Musk back in the day, Peter Thiel, Sam Altman, $1 billion backing. They were like, we're non-profit. We're going to make artificial general intelligence, like this holy grail, the super smart AI. We're planning to make that. We'll open source all our technology unless it's dangerous.
What could go wrong?
Right, well, exactly. So that was the plan in 2015. Fast forward a few years, Elon Musk drops out. We're not really sure why. And then they say, hey, so you know that non-profit thing? Yeah, we're still non-profit, but we're going to have a for-profit division within us where if anyone invests, we'll cap their returns. But they cap the returns at 100 times, which is such an insane level. It's stupid. There is no cap. So it's really not non-profit anymore. And with that announcement, Microsoft gave them another $1 billion. All well and interesting. Fast forward to this week, Microsoft says, we worked with OpenAI and we built one of the world's fastest supercomputers. In the top 5 ranking, according to them, no one's been able to independently verify it, but it's got 285,000 CPUs, 10,000 GPUs, a bunch of other technology, and they're using it just for OpenAI. We can't use it. It's on Azure. We can't get it. And they're using it for God knows what crazy AI. And it fascinates me and terrifies me because I don't think there's an AI supercomputer out there or AI company with that much access to computing power. Even DeepMind, even government research labs have to queue. They have to fight with other research labs to get access to the government supercomputers. So it's a huge development.
But this AI supercomputer, which interestingly doesn't have a name as far as we know, so we keep referring to it as a Microsoft's AI supercomputer. So they probably need to get that sorted at some point.
We should help them sort out. Like, what's a cool, like Summit, it's a good name, but it's not aggressive enough,
Well, so you've had Titan. Titan's my favorite supercomputer just from the name. Red Storm, that was the first supercomputer I ever wrote about. So that's got a special place in my heart.
The Shrugging Atlas.
Yeah, I mean, it is full of a bunch of people that love Ayn Rand, so
Yeah, the future Iron Ren wanted, it's finally been realized.
terrifying.
Oh, God help us all. All right. We started talking about hardware, and no matter how cool Microsoft's AI supercomputer, well, so the Shrugging Atlas, no matter how well the Shrugging Atlas might be built, it's still based on last year's technology because, the GPUs we presume probably Voltus, right? And last week, at their annual GTC conference, Nvidia has announced a new video card, which is probably is going to be a standard for several years to come, because that's how these things work with Nvidia. I mean, the company essentially, first made its fortunes on gaming, had a very, very interesting period in recent years where it was essentially bankrolled by cryptocurrencies. And then cryptocurrency hype started to die, and AI emerged and essentially created a new market worth several billion for Nvidia. And it's just like, I think Tractica guys have the numbers, and it's actually mad because this is a net new market. This is something that wasn't sold, had no purpose. Like sometimes technology just evolves and you have the new stuff replacing the old stuff. But in this case, this is like AI workloads are all new. This is net new market, and everybody's very, very excited about the amount of money being spent there. Anyway, long story short, we have a new state-of-the-art GPU. It's called Ampere A100. It's the biggest single slab of silicon Nvidia has ever put on a card, so the chip die is massive. And it also features Nvidia's interconnect called NVLink, which allows you to do an interesting thing. It's basically you can connect up to 8 A100s to create this sort of mega GPU with fantastic levels of performance. They say a single one is about 20 times as fast as an Nvidia Volta in some workloads. So imagine what happens when you link 8 of them together using a sort of like a new fancy interconnect, which gives you kind of chip line speeds. It's mad. At the same time, second thing this clever GPU can do is it can subdivide itself. You can shard it into 7 smaller GPUs. So instead of and each of them is still going to be more powerful than the previous generation silicon. This thing is mad. This thing is very, very flexible. It's also very, very expensive, and it's the new standard because all the cloud vendors obviously signed up and they're going to deploy it. Most server manufacturers, like usual suspects, like Dell, Supermicros, HPs, already announced servers with this thing on board. So for the next couple of years, get used to the idea of seeing Ampere A100 around.
Yeah, no, it's truly huge. They bundle it into DGX boxes as well, where you can kind of get a whole bunch of them in one go. And that alone, depending on the kind of benchmark you're using, is 5 petaflops of AI performance, which is...
Wow. While we're talking about the future of GPUs, let's talk about the future of warfare. That's not the best segue I'll ever do, but here it is. Let's talk about killer robots. Is the future of killer robot inevitable? Is that our future? AI is already in the modern warfare, is being used. Most importantly, China, America, and Russia just don't seem to care. They don't want to regulate it ever. I mentioned in the intro, all I can think about is the killer dog in Black Mirror.
I think the reality is scarier than the killer dog, because the killer dog is just the killer dog. You hide from that dog, it doesn't see you. Fine. What they're actually wanting to do is total surveillance and dominance. So it would be a killer dog with like a killer bird and a killer insect and a killer space eye, and all these things working cohesively together, so there is no escape.
Sebastian, we brought you here to make us feel better about the future.
No. Where does this information come from? So how are you so sure that the US Army is actually interested in these things?
Right, so this is my tip on how to feel better. How I feel better when times are stressful, and times are stressful right now, is I go onto government procurement websites and read through the fun documents that they have. And there are so many that just give you glimpses at what they want to build. So on the one hand, they do have an official AI ethics guidelines, and they will say, hey, we're not doing killer robots. But on the other hand, the amount of times you see autonomous robots for the military that they're looking for that potentially don't have humans in the loop, it tells a completely different story. So if you indulge me, I'll talk about one procurement contract that I came across the other day that no one's really looked at yet.
Please.
So this is the Thunderstorm Technology Demonstration Experimentation 21-1. And what it is what they want to build. This is a VR world where soldiers or whoever commanders would be able to interact and play with different autonomous systems and teach them, and again kind of work out how to train them and get them better at killing on their own. And in in that same document, it literally says inclusion in upcoming capability demonstration and experimentation event focused on virtual reality tools in support of enhancing small unit lethality.
And that's capitalized. Small unit
Yeah,
lethality.
that's a core part of it. And then deeper into the document, again, obviously a lot is redacted, and there's mention of top secret clearance that I would need to know more. But they talk about swarms of different systems, unmanned ground vehicles, unmanned aerial systems, which is again creating this overarching software platform for tracking everything, trying to predict everything as much as possible, and then kill everything. Yeah, I mean, again, it's an area where a lot of work has gone into it at different stages. IBM used to have something like that. Palantir, Peter Thiel's company, is pushing to develop their own platform for that. It's a huge money pit because the military-industrial complex is where all the money is in the world.
So last year, me and Sebastian, we worked together. Obviously, no coronavirus. So we ended up at the Defense and Security Equipment International. The key word at last year's DSA was 100% autonomy. We saw autonomous planes. We saw a demonstration of a fully autonomous boat. We saw some nice autonomous subs. Obviously, drones everywhere. So we've got the hardware basically. So while like it's just like there's interesting software projects, there's also hardware platforms to do it all already, and they're looking for buyers.
Yeah, I mean this is undeniably the future. It's a question of when, how extreme, whether there will be disasters. So in the Iraq War, there were times when different systems didn't interact properly, and you had anti-aircraft guns going against U.S. aircraft because they didn't talk to each other, didn't say, "Hey, I'm on your side." So we're probably going to see stuff like that. It's going to take time. There's going to be death, but there's also going to be death that they want. So it will be an interesting thing to watch, but hopefully from a bunker.
Great. I definitely feel better now. Well, let's talk about the human brain. Something we all have zero, to no knowledge about. I'm speaking for myself. I have no idea how it works. This is a question that's been posted, many times, and it stemmed from this TED talk done by Henry Markram claiming that in 10 years, within a decade, and this is a decade ago, we're gonna be able to map out the entirety of human brain, and we're gonna find out how it works. And this is a decade later. We haven't heard an update, and now the question is being asked: is that actually a good idea to create artificial intelligence based on a human brain?
So I actually spoke to Henry Markram a couple of years back, and so he's had to kind of revisit his idea that we could get there quickly and that this was something we could do soon. But so he told me, you have 1 billion organic proteins in a single cell, and the interactions are happening at a microsecond scale. If you wanted to model all of that in a human brain, you'd need a computer at about 10 to the 30 flops. That's in the yotta scale. And we're not at the exascale yet. We will be next year, but it's going to take some time to get there.
He's talking about mapping out. We're going through trees in the rainforest. What he also said is the human brain is still evolving, and are we going to map out this thing where it's still evolving and let it evolve, or are we going to put limitations to it?
Well, I mean, it's a question of is the aim to just simulate it an exact copy, and in which case we don't know enough about the brain to simulate it, even if we had the computing power. We don't have that visibility into what's happening in the brain. And then are you also simulating all the stimuli that impact the brain, such as your glands that give you different hormones? That will require insane levels of computing power that we are nowhere near. So there are other approaches. So if you look at kind of early neuromorphic computing that we're in, that try to take a much more simplistic and just look at certain parts of the brain and simulate them in a very, very, very simplistic way.
Yeah, and a note on neuromorphic computing, because our listeners might not be familiar with the concept. So the idea is traditional artificial intelligence, so like the one, the type we mostly talk about, is essentially done in software, right? They just like
Right.
the simulation of the human mind is in software, where they have the sort of like like approximations of neurons, essentially. Neuromorphic computing is something where this is done in hardware, where basically hardware elements represent synapses, and they're counted in synapses and not transistor gates like traditional CPUs. So again, very early days for neuromorphic technology, but there's a lot of interest, and especially like I know EU runs several sort of like important neuromorphic study projects. Again, we're talking this technology is gonna be a decade before it's like anywhere near useful, but yeah, there's progress.
Mm. Well, yeah. So Henry Markram, he started the Human Brain Project in Europe, and that's got a division within it that's working on the brain scales neuromorphic system. And then he's no longer part of that, but that's quite fascinating. And then the overall project there is to try and understand the human brain, mainly for things like dementia, because wealthy countries, we're all living longer. That's become more and more of an issue as time goes on.
It seemed to me just one of those things that where the more I read about it, the more questions I have. Like, sure, the capacity of a human brain, but what does that entail? How old is the brain? The brain of a 70-year-old man is different than a brain of a teenager or a 5-year-old. Our brain is changing cells every, and we're trying to develop this artificial intelligence, but it basically just end up being us understanding more about ourselves and say, oh, that's what caused autism. Oh, that's what caused Alzheimer. And I think that's what's fascinating about the whole thing, where it's less about the machine, but more about ourselves.
Yeah, no, I think, I mean, when we start getting there, there'll be deep questions on ethics and what it means for the human condition. But I would caution, if you look what's happening right now with this virus, a virus is a significantly more simplistic organism, and
Mhm.
yet we're rendered helpless. We have huge supercomputing initiatives and AI initiatives hoping to understand this virus and hoping to work out ways to defeat it, and yet we're nowhere near that. And this is a significantly more simple thing. This is the tiniest thing, and to look at that and go, hey, we can't deal with that, but we can do a human brain, it is insane.
Yeah, okay, and just to understand the sort of like the scale of things we can do at this moment in time. So I'm always sort of like keeping an eye on the Open Worm project. It's an international open source project where they try to simulate every single cell inside this worm called C. elegans. I'm not going to pronounce the whole sort of like name.
It's my favorite worm.
It's a 1 milliliter long, tiny little beastie that lives in the soil, and we can't simulate every single cell in that little thing yet, but we're getting close. So basically, at first, they're kind of simulating its locomotion. 302 neurons, 95 muscle cells. That includes sort of like all the components of the cell. So like it's just like, yeah, in terms of mapping out life on this planet, we're currently looking at a tiny 1 millimeter long beast, and we're finding it very, very hard to do.
But on a more positive note, it does tie back into the military, because of course they're working on it. So HRL Labs, out of Howard Hughes' old research labs, they have the Neuromorphic Eyes in the Sky program, which comes together with Nemesis. And the idea is there to put neuromorphic systems inside drones. Because what we didn't talk about was part of the reason we want to emulate the brain on a short-term basis is because it's so much more energy efficient. Right? The human brain is around 20 watts. Now, we were talking about those supercomputers that are tens and hundreds of megawatts, depending on how extreme they are. This is so much more energy efficient. So you put that in a drone, the drone can fly a lot longer, do a lot more surveillance or death from above or whatever it's meant to do.
Right. So you're saying this is on a positive note.
Well, the
and
positive
bring us back to warfare.
The positive is that people are working on this. As scary as the military is, these things generally filter out into the mainstream. Most great scientific advances of the modern age came out of the military. So stay tuned. It will come into your iPhone at some point.
So on one side, death from the sky. On the other side, faster video games.
Yes.
So we'll have more stuff to do in the bunker.
Yeah, exactly.
This is the point where I need to remind our listeners, we are launching a new website in the middle of June, so keep an eye out on the website. It's going to go through considerable changes, hopefully going to become a lot more user-friendly, a lot more useful to your needs. And yeah, we're going to be launching several kind of editorial initiatives, and we also have a long-running reader survey on the website. So if you want to tell us what you feel about what we're doing, just click on the link and do let us know.
And Sebastian, where can people find you?
On Twitter at Seb Moss, on LinkedIn at my name, but I don't know why there's nothing on there. Twitter, where you'll get my mad ramblings and other government contracts that I found that I can't turn into articles. So, for example, Weapons Pitch Day tragically got cancelled recently because of COVID. So,
Wow, how dare they?
yeah, so if you were looking forward to pitching your innovative weapon, that is no longer a possibility.
Should I just tweet it right at you and send it right to you?
Yeah, feel free. My DMs are open for giant weapons of mass destruction.
Max?
Yes, you can find me on Twitter, and I've recently joined Instagram to be, like down with the kids a little bit. Like a modern all-purpose media editor. I've got one picture there, and it shows me cycling on a bike. Which if you listen to the previous episode, I've bought an electric bike, and I recommend you do the same. It's the best money I spent in lockdown.
Good stuff, Max. I'm waiting for you to post your first Starbucks cup with your name on it when the lockdown's over. Thanks, guys. We'll talk to you guys in 2 weeks.
Thanks for having me on.
Thank you, and see you in a couple of weeks.